All attendees are in listen-only mode.
Good morning and good afternoon, everyone. Thank you for joining us for our webcast today. We'll be presenting creating animations using mechanism design in Creo today. I'm Matt Tognorelli, and I will be your moderator, and Nitin Sharma will be our presenter for today's webcast. The quick agenda: we'll begin with a brief BWI intro, who we are, how we help manufacturers with solutions across the product lifecycle for those who are new to our webcast series. Then we'll go right into the presentation around creating animation using mechanism design, along with a live demo. Then wrap up with Q&A at the end. You're currently in listen-only mode, but you can write in your questions throughout the webinar, and we'll make sure to get them answered at the end of the webcast. Barry-Wehmiller International is the global engineering and enterprise consulting division of Barry-Wehmiller, a U.S.-based manufacturing leader with over 11,000 team members and operations worldwide, going on 130 years of business, approaching $2.5 billion in annual revenue. Our division provides total solutions across the product lifecycle, helping manufacturing leaders drive more business and engineering value. Barry-Wehmiller has a rich manufacturing legacy tracing back to 1885, serving all sizes of business, ranging from small and mid-size to Fortune 1000 manufacturers. We provide solutions for a diverse group of customers spanning the globe in Europe, Asia, and the U.S., from small companies to large household names and everything in between. We have three quick poll questions real quick, and then I will hand this over to Nitin. First question is, what version of Creo are you currently using? Alrighty, thanks. Next question. Alrighty, and one more here real quick. And we'll turn it over. And with this one, you can answer multiple answers to this question. All right, thank you everyone for voting. We'll wrap this up. And I'm going to make Nitin the presenter and hand it over and let him presentation here. All right, Nitin, we can see your screen.
All right.
Thank you.
So, hello and good afternoon, everyone. My name is Nitin Sharma, and I work for BWI as a Senior Applications Engineer. Welcome again to our new webcast today. In today's webcast, we are going to show you some capabilities of Creo Parametric for creating animations using mechanism design. This is going to be an agenda for today's webcast. First of all, we are going to identify differences between MDX and MDO. Followed by that, we will discuss the mechanism design process along with some examples and demonstrations. And finally, we will look at the animation capabilities as well. Now, first of all, to identify the differences between mechanism design extension and mechanism design options, we have two different images over here. Looking at the topmost image, we will see that we have all these different groups that have all the different commands and are available for our mechanism design extension. This MDX is only a kinematic design package that would allow you to perform position and kinematic analysis along with the use of servo motors. But with MDO, you can add forces, spring motor, torques, extended mass property functions. Not only MDO will allow you to perform kinematic and position analysis, but also you can perform dynamic, static, and force balance analysis as well. As you could notice right over here that if you have access to MDO extension, along with all these options that are available with MDX, we would have access to force motors, force torques, bush loads, dampers, gravity, and also specifying initial conditions. Now, moving after this to our next slide over here, we can see that we have all these several different steps that are recommended by PTC for a typical mechanism design process. Not only this, using the mechanism design, you can detect collision between moving parts and quickly understand the kinematic implications of design changes. This last step that we have over here, that is known as the post-MDX process, is optional in many cases, but today I will be going over some of the mechanism animation procedures. Now, talking about all these steps over here that we have, the first one that we have in the list is creating the model. Whenever we do go and create our models using our component placement dashboard, we have access to all the constraints and all the connections that are available to us in mechanism design. Now, once we go and use this dashboard over here, we can simply go and select the type of connection we want to use for the placement of our components. Now, these connections are nothing but predefined set of constraints that constrain motion while still permitting various degrees of freedom. If we look at in this list right over here, these are all the different connections that are available to us. And out of this list, the top four that we have over here, known as rigid, pin, slider, and cylinder, are the most commonly used ones out of this list. Now, once we have our models created, the next thing that we do is we go and verify its motion. This is an important step because it ensures that the connections produce the desired motion on the parts with respect to each other. Now, in order for us to verify the mechanism, we have two different options available. One thing that we could do is we could go and use the reconnect command from our mechanism dashboard, and this particular process is also known as connecting the assembly. If your assemblies are already connected, running this analysis does not move your mechanism. Now, if we do want to go and see if our mechanism works the way intended, we can also go and use this tool known as drag components tool to manually verify the motion in our components. Now, for our today's demo, we are going to build this model from scratch. That is, we are going to use all the different types of connections to assemble these parts together. Once we have assembled these parts together, we can go and use our drag components tool to verify the motion intended. So I will simply go select a point on this model and go and check the motion. Now, once we have our mechanisms verified, the next step that we have in the list over here is adding mechanism entities. Now, in our mechanism design, we add servo and force motors to specify position, velocity, and acceleration of a mechanism. Not only that, these motors drive the model's motion and are also what adds the animation to the model itself. Now, if we do want to go and add any of these mechanism entities, first of all, we can go to our Applications tab from Creo Parametric, and from the Applications tab, we can simply enable our mechanism dashboard. Under our mechanism dashboard, if we do want to go and add any of these mechanism entities, we can go to either our insert group or the property conditions. In this particular case that we have over here, we already have a couple of servo motors that are defined. And based on the configuration of these servo motors, we have also created an analysis over here that is a kinematic analysis. Now, guys, once all these steps are defined, we can simply go and run our analysis to check the motion of our parts intended as based on the servo motors that are specified. Now, usually once we have the mechanism entities added, we go and prepare for analysis. Now, for preparing for our analysis, we define measures before running an analysis because they are then evaluated as the mechanism analysis moves the mechanism through its defined motion. Measures are also important because they can help you understand and analyze the results of moving a mechanism and provide information that you can use to improve the mechanism's design. You can also create measures to evaluate position, velocity, or acceleration for points or motion axis in your assembly. Now, also talking about performing the analysis itself, if we do have access to MDX, we will be able to perform kinematic and position analysis. If we do have access to MDO extension along with position and kinematic, we can also perform dynamic, force balance, and static analysis as well. Now, once we have performed our analysis, the next step that we have over here is the post-MDX step that is also known as evaluating the analysis results. Once we have the analysis results, we can plot the measures on a graph individually, or we can create composite graphs of multiple measures. And also, once we have our analysis results, we can go and use these results for creating animations and also use the results to take snapshots that can be also used in our drawings. Now, one such example we have for our animations is right over here in this little clip. Now, as I said, what we are going to do from here is we will go and create this model first of all. Once we have this model created, we would follow all these steps for creating the mechanism design process. Now, over here, I'm going to start with an assembly with the loader base part. And followed by that, I will one by one bring in all the components inside our assembly. Now, looking at this dashboard right over here, on the left-hand side, we have this drop-down that gives you access to all the different connections that are available. So for the placement of this ARM tab, we are going to use our pin connection, and also we will select our geometric references for that. Now, very similarly, once we have a connection defined, we can simply go and verify if that connection works properly by simply using our drag components tool over here. I will simply select a point on our model over here and move our cursor to check the intended motion. Now, followed by this, we will simply go in here and bring in all the components in our assembly. And also connect it using the different connections that we have in here. Now creating another pin connection on this end for the bucket and the arm. And also finally placing our second piston. And for this piston as well, for first end, we are going to create another pin connection. And we are going to use a cylinder connection at the other end. Now, as I said previously, once we have the model created, the next thing that we usually do over here is we verify these connections. And for verification of these connections, we can always go and use the drag components tool and move our components around to check the motion. Now, not only that, for all these different parts and some assemblies that we use over here, we also go and define something known as the regeneration value, or also called the home value. So just if we do go and look at this piston component right over here, or a piston subassembly, this piston subassembly is nothing but the cylinder part along with this yellow cylinder part. Now, just to show you over here, if I do go back to the dashboard for placement of this component, we could notice right over here that a value of 120 is added as the regeneration position. So what this regeneration or the home position means is, if we do go and drag these components to a different position, every time that model is regenerated, this particular component will go back to its home position or the regeneration value that is set. Now, once we have defined all these different home positions, we can simply go to the Applications tab and activate our mechanism dashboard. In our mechanism dashboard, all the joints that we have created using the different connections are highlighted with different symbols. Now, not only can we use Creo Parametric to set the regeneration values of these connections, but we can also go and use our mechanism tree. So again, changing the home position or the regeneration value of this subassembly to 80 and doing similarly over here. Now, once we have made our changes, we can regenerate our model and use our tool again to check the motion of our components. And now, also if you would notice, as soon as I would go and regenerate my model, these components would go back to their original location or the regeneration value. Now, once we are inside the mechanism mode, we can go and use the servo or force motors to drive our mechanism's motion. And that can be done by either using our mechanism tree or using the insert group from the dashboard itself. If we do want to go and add any of these servo or force motors, they can be added to any of these motion axis or geometric references. In this specific case over here, I want this particular connection to be driven using a velocity profile that has a constant magnitude of 6. And just to show you, we can always go and create a graph of it. That is, in this particular case, we have velocity against time. And I will apply this motor. And similarly, I'm going to use the second connection that we have over here, and I'm going to add another velocity motor that has a parabolic profile. And also, if we want to go and check out the profile, we can always go and use the graph tool as well. Now, once we have our motors added over here, the next thing that we usually do is we go and specify the different measurements that we want as an output. In this specific case over here, once we have ran the analysis, I want the system to calculate the position of this point that we are selecting, and I want the system to give me the magnitude for the position of this point using the x direction and the maximum value for it. And another measure that I'm going to create over here, it will calculate the velocity of this point, again, in the x direction and the maximum value for it. Now, once we have these servo motors defined and our measures defined, we can simply go and create a new analysis. Now, based on if we have access to MDX or MDO, we will be able to create all these different types of analysis known as position, kinematic, dynamic, static, and force balance. Either of these analyses that we are going with, we also go and define our preferences, that is the duration this analysis is going to run for, along with the frame rate. Not only that, we can also go to our motors tab to specify which one of these servo motors added to our models would be used during the analysis. Once we have defined our preferences, our motors, and also the type of analysis we are running, we can give it a meaningful name and run the analysis right from here. Now, if we do want, we can simply go and create as many analysis definitions we would like using either our mechanism tree or this icon from the analysis group. Now, once we have an analysis run, we can always go and check out the results for our measures. Now, for checking out the results for our measures, I will simply select the definition of the analysis we have run, and the system will show us the value for those measurements. Also, as I said previously, not only we can go and look at the values of these measurements, we can also ask the system to create or plot a graph for them. So right over here, we have an example for the measurement that we created for the position of the point. And you would notice, based on the duration, how this analysis is run, that particular point is offset in the x direction. Now, not only can we go and look at these graph tool outputs, we can also go and play back the results of any of these analyses by using the Playback tab. Using this Playback tab over here, we can simply click on this icon and it gives us access to this little dashboard using which you can play these animations. Now, at any point of time, whenever you are playing these animations, you can control the speed at which this animation is run. You can stop or reverse it at any point of time. Not only that, you can also specify whether this animation keeps going in the same loop or it reverses directions once it's completed. Now instead, if I want this animation to reverse directions, I can simply toggle on this icon. So once the animation is ran through its full cycle, it reverses directions. Now, using this little dialog box over here, not only we can go and look at the results of any of these analyses, but also we can export or capture these animations. If we do want to go and export these animations, first of all, we can select the type of extension that we need out of the list. Also, we can specify the frame rate right from here. And also, if we want these frames to be photo rendered or not. Now, the last thing that I would need to go and specify in this specific case over here is where this specific animation would be saved and what would be the name of this animation. Now, once we have specified that, we can simply say OK, and what the system is going to do is it's going to run our animation based on the analysis we have defined, and it will also save that as an animation file. That is an MPEG. And now, just to verify that we have this animation captured, right over here we have is the file and the name that we specified to it. And if we do want, we can simply go and run it at any point of time, right from our desktop. Now, going back to Creo right over here, one thing that we have already noticed that can be done using this Playbacks dialog box is we can simply go and run any of these animations. Now, not only can we go and run any of these animations, we can also go and either save these results or import the results that have been previously saved. Right here. Now, another thing that can be controlled about our animations in mechanism is whether we want the time to be displayed in the background when the animation runs or not. So by default, the time is displayed while an animation runs. So if you can notice right over here. But if we do not want this time to be displayed, we can simply go and uncheck this box over here. Now, one more thing that also can be controlled from here is this default schedule. By default, the system will run this animation based on the duration that is defined. So just to verify, if I go back to my analysis definition, you would notice that I have specified the duration of this particular analysis to be 50 seconds. Now, if I do not want this particular animation to be ran from the starting time to the end time, we can simply go and manipulate it using our Playback dialog box. So in order for us to do that, I will simply go and uncheck this box over here. And just for sake, if I want this animation to be ran in reverse, I will simply go and change the order for our starting point and the ending point and will add it as a schedule. And once we have that schedule added over here, we can go and run our animation. And again, if I do want, I can simply go and add as many different steps and manipulate how this particular animation will be run based on the duration that is specified for all these sequences. Now, gentlemen, in this case, you would notice our analysis is going to run from its endpoint to the starting point, and back from starting point to a quarter of way along the whole duration. And once it reaches the starting point, it's going to reverse direction again, and it's going to stop at the specified time duration in our mechanism, that is 20. A little less than halfway of the duration. Now, at any point of time, if we do want to go and get rid of these time clips over here, we can simply come here and delete them. Or if we want the animation by default to be run from starting to the end, we can always go and use the default schedule as well. Now, one more thing that we can also do to make our animations look more clean is we can always go and control the display of entities inside our mechanism dashboard. So if I want, I can simply go in and check all these boxes over here, and that will get rid of all the symbols and icons. And once I have done that, I will go and run my animation again. Now, another thing that you would notice right over here that can be done is if you have multiple different analyses ran, you can simply go and select the results from any of those analyses and save them or delete them. Not only that, the results from any of these animations can also be used for the creation of motion envelopes. For the creation of a motion envelope, you will simply go and specify the quality level for it, and also you will specify the output format that you need. And if you do want to go and look at the preview, you can do that as well. Now, not only that, one more thing that can also be done from here is any of these results that are available to us from our measurements can always be exported to our Creo parametric parameters. So if in case we need to go and use this particular value from the measurement, it will be available to us in our parameters list. So just to show you an example, if I do go and add this particular measure to our parameter list, I can simply go to my tools and access them. And right over here is the measure that we have just added as another parameter in our model. And not only that, if we want, we can always go and use any of these parameters from here to run a motion analysis using Creo Parametric. So right over here we have is the measure that we calculated, and if I do want the system to create a motion envelope, I can simply go and specify a component and run it. And right over here we have is a motion envelope created based on the motion analysis we are performing right over here. Now, one more thing that also can be done using our mechanism dashboard right over here is, if we do want, we can also ask the system to create a trace curve. So if we do want the system to create any of these trace curves for us, we can simply go and use this functionality, select the component that is going to be used as a reference. Followed by that, we can also select the point that we are going to use for the creation of this curve. And also let's import in our result set. So right over here. So if we do want, we can always ask the system to go and create these trace curves for us that will locate the motion of a specific point that is selected for creating the trace. Now, last but not the least that we are also going to talk about over here are our animation capabilities. All right. Now, once we have any of these animations created and saved from our mechanism, we can always go and input those animations into our animations application directly. So right over here, I'm going to import this animation and let's run it once again. And what I'm going to do from here is I will simply go and save this playback with .pbk file extension. And once we have this file saved over here, we will simply close our mechanism app and instead use our animation app again by going to our motion group. Now, if we do want, we can go and create multiple animations using this animation application. If we do want, we can simply import any of those animations that were created using mechanism design. So one such animation that we just created and saved is available to us right over here. So I will simply import it in Creo. Now, once we have that animation imported in here, we can always go and play it back, just like how we did it from our mechanism dashboard itself. Now, not only that, another thing that we can do over here is if we want to go and manipulate these animations, we can go and add some objects from our animation application itself. Now, first thing talking about over here is the orientation of our model. What if I want this model to change the orientation as this particular animation is run for the duration that is starting from 0 to 50? I will simply go to the view time over here and specify the orientation that needs to be set at the starting of the analysis. Now, once you have done that, if I want the orientation of this model to be changed to default after 20 seconds or this 20 duration, I will simply go over here, select that orientation, and also specify the duration I want this particular orientation to be applied. Now, once we have these two view times added to our analysis definition, we can see and verify if these changes work. So, based on the timeline that we have created, I want the system to automatically change the model's orientation to front when the analysis starts. And at this duration that is 20, I want the system to automatically change the orientation of my model to default. So again, if you would notice right over here, as soon as I reach this duration, the system automatically changes the orientation of this model to default. Just for sake, what if I want this model to go back to the front orientation around this location? I can simply go and add it as another view on the time by specifying the orientation and the duration as well. And just to verify that, we will go and run our animation again. Now, Not only can we go and control the orientation of our models while running an animation, we can also go and control the transparency on those models. Just for sake, after halfway this analysis or the animation is run, what if I want this bucket part to be transparent? What I can do is I can simply go and add transparency to it. For that, I will simply select the component, say OK, and specify the transparency level. And also I will specify over here when this particular component becomes transparent. That will be halfway along the length of this animation. So I'm going to change the time to 25 after starting, and we will go and run our animation again to verify all these changes are applied to it. And if we all can notice right over here, this is where on our timeline we have added the transparency. So if at any point of time, if I do want to go and change the transparency level or the position of it on our timeline, we can simply come in here, double left click it. Once we have selected it, we can change the transparency level, and also we can change along our timeline the location of it. So let's try and run our animation again. Now, another thing that we know over here is at any point of time, if you do want to go and play back this particular animation, instead of having the create activated, you can activate the playback tab. And once our playback tab is activated, we can simply go and run this animation either in forward or reverse motion. Not only that, we can also go and control the timeline of this animation simply by holding our left click on top of it. Now, once we are satisfied with the animations that we have created over here, we can simply go and save those animations as well. And again, just like our mechanism tab, we can simply go and specify the name of the animation, followed by the extension that we want, and also the frame rate. Now, one thing that we can also go and do over here is we can also control the display style state of our model along the timeline of our analysis. Now, in order to go and look at this particular option over here, let us go and save our analysis and go back to our Creo Parametric. Now, we very well know over here is that if we want to go and create a new display style for our components in an assembly, we can always use the view manager, specify a meaningful name for that style state, and create it. And also, I will simply go and modify the display style for all these components individually. And once we have made those changes, I will simply go back and save them. Now, going back to our animation portion over here, as I said, if at any point of time along the timeline of our animation, if we want the display style of a model to be changed, that can also be done using this style time over here. So, for this current model, I want the system to start with our default display style at the beginning of the analysis. Once that is done, I want the system to automatically toggle to the style 1 that we created for this assembly over here, and I want the system to do it after halfway along the timeline of our animation. So the total duration of our animation is 50, so I'm going to place it halfway, that is 25, and we'll go and verify it. So again, in this specific case, if you would notice, what the system is doing for us is, after almost along halfway, that is 25, it automatically changes the display style of our model to style 1. Now, if we do want to go and make any changes to the duration when these changes are applied or the style itself, we can simply go over here, select that style, double left click to edit it. So if I want these changes to be applied after, say, 15 seconds on our timeline over here, I can simply go and adjust it and rerun our animation again. And now, once we are satisfied with any of these animations that we create in here, we can always go and check out the playback, play the animation in forward or reverse direction. Or also, we can save any of these animations. Now, one more thing that also can be done using our mechanism design is, one thing that we noticed over here was, if we do want to go and verify the motion of the different components in our model, we can simply go and manually drag any of these components. Not only can we go and drag these components using this tool, we can also capture different snapshots for the different locations of the model in our assembly. Now, once we have captured these snapshots over here, we can simply go and use these snapshots to take our components back to the captured location. And not only that, any of these snapshots captured over here can be made available to configure the different views in a drawing. So if I just want to go and use these 3 snapshots right at the bottom of the list, and I want these snapshots to be made available in our drawing, I can simply go and do that. And now, just to verify it, once we have created these snapshots, let us go and try to create a drawing. And for the creation of the drawing, we are going to use the same model, and we are also going to use this template over here. Right. Now, at any point of time, if we do want to go and change the configuration of these models based on the snapshots that we have taken, it can be performed right from here by going to our drawing properties dialog box, and that is available from the view states. So if I do want to go and show the different configurations of this model in these views, I can simply go to the drawing view properties dialog box, and by accessing the view states from here, we can use any of these snapshots. And once we have these snapshots over here, if we want, we can go and populate our drawings with the different dimensions that are needed. Right. So that is something that these snapshots allow us to do, that is capture the different position of our components that can be configured for the different views in our drawings. Now, going back to our animation capabilities over here, one thing that we have noticed over here so far is at any point of time, if we do want, we can simply go and run these animations using our playback tab over here. All right. All right. Right. And once we have this analysis run over here, we can simply go and look at the playback. But if we do want at any point of time, we can always go and further manipulate any of these animations along with our animation application as well that is available from our applications tab. And guys, that is all that we have today for our today's webcast.
Thanks, Nitin. I'm going to take over here. We did get a few questions throughout the webcast. And,
yes.
We'll get those here real quick. Sorry about that, folks. Alrighty. Let's see. First question we got here, Nitin, for you is, what's the difference between a pin versus a cylinder connection?
Okay. So a pin connection would allow you to rotate a component about an axis or a cylindrical surface, but at the same time it would restrain the translation of the component. But in case of a cylinder, it only allows the rotation of the component along with the translation as well.
Okay. Next question is, what happens if regen positions within assembly conflict?
Okay, so in those cases, whenever we go and run that reconnect command, it is going to give us an error, and it is also going to tell us that the assemblies have invalid configuration. So it would not allow you to run these animations or the analysis.
Okay. Let's see. I see the pistons are separate model files. Can they be the same model file and still be used in the mechanism analyses?
So I'm not sure about this question, Matt, but if I understand this question correctly, in the model that I was using, I had this model over here that I had a subassembly for. But if we want, we can always go and take these components individually to the top level as well and use them that way.
Okay.
So if that is the question, then yes, we can go and take these models individually to the top level assembly and use them that way.
Okay. Robert, if that didn't answer your question, go ahead and see if we can clarify that a little bit, and we'll see if we can get him to answer it. Next question is, when assembling the piston, you used a pin and cylinder connection. Would a pin and pin also work?
Yes. A pen and pen would also work, but if you are using a pen for the other end, you would need to select another set of references to define the placement of that component. Yes, but it would work.
Okay. Alrighty. So we have in the way of questions. We'll do some other business, see if we get any more questions before we close this out here, guys. If you are looking to take any other Creo or Windchill classes, we provide certified training in 6 different training facilities across the U.S. You can do on-site training as well or virtual training. Feel free to browse our training schedule. Visit our website at b-wi.com/training, or you can reach out to our National Training Manager, Joe Ferret, directly. If you have any training questions, he'll be able to take care of you or your team's needs as well. Also, the Get Active campaign that we spoke about earlier, when you trade in your old license today, you get and get a new subscription license. You can save up to 80%. It's a multi-year agreement. You can lock in with a low price, and your annual subscription covers software support and training and one payment. Let's see, we got another question here. Can components with properties of magnetism be utilized to show attraction?
Matt, to the best of my knowledge, I do not think you can do that using mechanism.
Okay.
But that is not 100% answer. I can definitely look into that. But so far, to the best of my knowledge, I don't think so it can do that.
Okay. All right. Yeah, William Nitin will look into that, and we'll get back to you on that one. Let's see, and Robert came back to kind of clarify the earlier question. Said the situation I was thinking of is if the pistons were the same model file assembled multiple times, but they have different regeneration states during the analysis, does Creo handle that?
Yes, it would handle it if you are assembling both those components at the top assembly level. So yes.
Okay. Alrighty. Does mechanism calculate deformation and stress?
No. So if we are interested in calculating deformation and stress, instead of using mechanism, we use simulate.
Okay.
That is Creo simulate.
Yep. Okay. Alrighty. Looks about like all the questions that we have here. We've got a few more closing slides here, and if you do have a question, go ahead and submit them, and we'll get them answered as we go through. Reminder, we do archive all of our webcasts on our website, b-wi.com/webcast, for you to view later and share with others. Also, next month's webcast will be design optimization using behavioral modeling, and we'll send out an invite shortly about that if you'd like to join us for that webcast as well. And if you have any questions about today's webcast, send any technical web questions or requests to myself, matt.tognerelli@b-wi.com. My contact is listed on the screen here, and I'll be able to take care of any requests that you may have. And with that, we don't have any more questions, Nitin. So thank you so much, everyone, for joining us today. We look forward to seeing you at our next webcast. Have a great day and have a nice weekend. And if you're in the heat dome like the rest of us here in St. Louis, stay cool. So So goodbye, and thank you all. Have a good day.
Matt, you still there?